In this video, I'm going to be explaining interpolation, and I'm going to do that with this frequency distribution table. But before I can do that, I have to get this filled out a little bit more. I need to have my cumulative frequencies and my cumulative percentages. I was going to do that before I started into the video, just to have them already set up for you, but I figured I could take an opportunity once again to show you how this works. So a cumulative frequency means that starting at my lowest value, so my lowest category here, where the score is 4, I have a frequency of 2, and so that becomes my first cumulative frequency. That's always going to work that way. What happens after this is I'm going to continue to work through the frequencies, adding each one of them as I move up to my higher and higher cumulative frequencies. So for example, there are 2 people who scored 4. How many people scored 5 or lower? Well, these 3 plus these 2. 3 plus 2 gives me 5. I keep that reasoning going until I'm finished. So if I want to know how many people scored a 6 or lower, that's going to be 8 plus 3 plus 2, which makes 13. If I add the 4, that will bring me to 17, and if I add the 3, that will bring me to 20. So these are my cumulative frequencies, and your cumulative frequencies should always end up at the very top category being equals to n, which is just the sum of f, which is 20. If you add up this column here, you'll get 20. Cumulative percentages are simply taking your cumulative frequencies, dividing by n, and then multiplying by 100%. So if I did 20 divided by n, which is 20, that's 1, times 1 by 100%. 1 times 100% is 100%. On the other hand, if I had 17, that would be 17 over 20 times 100%. If you work this out, it comes out to 0.85 times 100%. That is 85%. 13 gives me 65%. 5 gives me 25%. And 2 gives me 10%. Okay, so this is where I can start explaining what interpolation is. Actually, before I do, I guess there is one more thing I should say. The reason that I would ever want to have this cumulative percentage table or column as part of my table is because it allows me to answer questions about percentiles and percentile ranks. And just as a reminder, a percentile and a percentile rank come from 2 different columns on this table. The percentile rank is the cumulative percentage. So for example, this 85%, it is a percentile rank for a particular percentile. Percentiles almost come from the score column. Percentiles are the upper real limits of your scores. So they would be, for 8, my upper real limit, or the top of this category, which spans from 8.5 down to 7.5. So 8 covers the category from 7.5 up to 8.5. The top is 8.5. The top of the 7 category is 7.5. The top of the 6 category is 6.5, and so on. So these percentile ranks go with these percentiles. So for 85%, that is the percentile rank that goes with the percentile of 7.5. So if they asked me what is the percentile rank for 7.5, I would say it's 85%. If they said what is the percentile for 85%, I would say it's 7.5. So those are the sorts of questions you would get regarding these 2 terms. It becomes tricky though when they ask you a question for something like this. If they say, what is the 50th percentile? Okay, if they're asking me for the 50th percentile, that's like asking me what goes with 50%, We know the percentile rank, so in this question, the percentile rank is equals to 50%, but what is the percentile? So this one's a little bit more challenging because you can see that 50 is not actually on my table. There's no 50% listed on the table. It simply just falls somewhere between 25% and 65%. So this is where interpolation comes in. Interpolation allows you to find a value that is between two known table values. Interpolation, if you look this up on the internet, you'll find interpolation is used in many, many different courses for many different reasons, but it always ends up coming down to trying to find a value that's between two known values. It's certainly not going to always have to do with statistics. It won't always have to do with percentages. It's just anytime you have surrounding values and you want to find a value in between, that's where interpolation comes along. It can be kind of tricky, so I'm going to break it down into the simplest steps that I can. For the most part, these are the same steps that you'll find in your textbook. I probably just word them a little bit differently, and of course, I'm going to walk you through an example as I do it. To get that going, I'm going to clear out all of the unnecessary information here, and then we can get to work on figuring out the 50th percentile for this distribution. Okay, so if we have a question where we understand what the percentile rank is, 50%, and that's between two known percentile ranks, so we've got 25 and 65% here, and we want to find the corresponding percentile that is going to end up also being between the same two categories. So my answer is going to be somewhere between 6.5 and 5.5, because if we had 65%, that would go with 6.5. If we had 25%, it would go within this category with 5.5. But because I'm in between over here, I'm also going to be in between over here. So if we've got this kind of a setup, what you should start off by doing is getting rid of most of the table and just focusing in on those categories. In fact, just focus in on the relevant numbers. So 6.5 and 5.5 are the percentiles that are surrounding my unknown percentile. And let me keep this looking like that. Okay, and then on the other side I have my known percentile rank, so 65% and 25%, and of course in between we have our 50%. That is what the question focuses on. And so again, we're trying to figure out where does that 50% point on this side. Okay, so we can just focus in on this. We don't need to think about the original table anymore. Now the reason that I wanted to highlight this is because I'm going to be drawing, I'm going to be doing some little sketches in here. And these sketches are going to highlight some quantities that I'm going to be talking about. First amongst those are going to be the width of each interval. And by the width, I mean this. To get from 65 from the top down to the bottom of this interval, I have a width equals to 65 minus 25. The width is 40. We've dropped 40 percentage points there. So that's 40%. I'll just leave it as 40. Over here on this side, I also have a width. But of course, these are different values, so I'm going to have a different width. The width over here is equals to 6.5 minus 5.5. That is 1.0. So I have two widths. In order to keep track of these properly, I'm going to label these according to which columns they're dealing with. So for example, these are my percentile ranks in this column, whereas over here, these are my percentiles. So I'm going to call this WP for percentile. I'm going to call this WPR. Okay, so I have two widths. That is my first step. The first step is, let me actually write this in a way that you can see it. So my first step is to find the width of both intervals. And so this means finding the width for the percentile side and the width for the percentile rank side. So we've done our first step. There's only a few steps, so we're going to be done this fairly quickly. Knowing these steps off by heart might be important in your class, depending on whether or not you're allowed to record these steps on a cheat sheet. If you have to memorize these, the best way to do that would be to do a ton of these examples. They're not that difficult once you get the pattern down. So we just have to find the width on both sides. So we've done that. The next thing that I have to do is I have to find the fraction. The fraction of the known value where the fraction is equals to the distance from the top of that interval over the width of the interval. So what do I mean by that? Let's actually make that a little bit clearer. Distance from the top over the width. Okay, so that's my formula. I have a known value. My known value is the 50. What is the distance from the top? So what is the distance to get from 65 to 50? Well, from 65 to 50, that is a distance of 15. What is the width of that interval? So the width of that interval is 40. So I find the distance on this side to the known value, and I have to put that over the width of that whole side. So 15 over 40. Let's see what that is. 15 divided by 40 is equals to 0.375. Okay, so that's my fraction, 0.375. So that's my second step done. My third step says that I have to use that fraction to find the distance on the other side. From the top. So what I mean by that is I don't know what this value is over here. So I'm going to use this fraction, the 0.375, to find the distance from the top of that interval. So how far do I have to travel down from 6.5? And it works like this. The distance is equals to the fraction times the width. But it has to be the width on the unknown side. So everything is now happening over on this side. We start where we know all of our values, and then once we find the fraction, we have to move to the other side where we don't know everything that's going on. So this is going to be the width on the percentile side. So this is going to be 0.375 times, what is the width here? It's 1.0. And so this gives me an answer of 0.375. So if I traveled from 65, if I traveled 15 to get from 65 down to 50, over here I'm going to travel 0.375 to get from 6.5 down to our unknown value. Now we still have one last step to fit in here, so I'm going to have to make some more space. I guess I don't really need this table up here anymore, so I'm going to get rid of this. All right, so my fourth step is to use the distance that I just found from the top of the interval from the top to find the unknown value. So I have 6.5, so my unknown value is going to be equals to 6.5 minus the distance from the top, 0.375. And so this one ends up being 6.5 minus 0.375 gives me 6.125. And so that is my answer. It's 6.125. That is the missing value that's over here. And so let's just fit that in. It's 6.125. So 6.125 is that percentile that I was looking for. That is the 50th percentile. So 6.125. Okay, so I'll show you how this fits back in the original table. All right, so remember, we were looking for the 50th percentile, which goes with a percentile rank of 50%, but 50% falls in between these two. Well, if we move this all the way over, we knew it was going to be somewhere between 5.5 and 6.5, and it ends up that the value is 6.125, which means that 50% of scores are equal to or less than 6.125. And so we used interpolation to find that answer.